So 1 times 1 is 1. 2 times 2 is 4. Then 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 194, and 225. I believe that's up to 15. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes. So these are the perfect squares from 1 through 15. Everybody understand where I got those numbers? I just multiplied them by myself in my head. Now, when I was just telling Mr. Adam, and when I taught in traditional high school, I would have my geometry students and I would test them. They would have to have them memorized up to 20. So they'd go 5 more out. And the reason behind that was they would have to take SATs and ACTs, and knowing your perfect squares out that far saved you a lot of time on that test and made it so that you could just do things quicker on the test because it was a timed test. So we use perfect squares because when we're when we are simplifying, you want to try to find the largest perfect square that goes into this number equally. So what's the largest number on top here that could go into 50 equally? 25. 25 times 2 is 50. Everybody agree with that?
Yes.
Now, the perfect square can come out. The other number stays underneath. So this would be 5 square root 2. What about 72? What's the largest perfect square that can go into 72? Yep, it's 36 times 2. The perfect square that can come out is 6. That 2 stays behind. What about 32? What's the largest perfect square that goes into 32? 16. So I put 16 times 2. I pull this out. The square root of 16 is 4. And then 2 stays behind. What about 18? What's the largest perfect square that goes into 18? So 9 times 2. The square root of 9 is 3. And then we have 2 left over. Now I have some numbers out in front. When you have numbers out in front, you have to multiply whatever you pull out in that first number. So let's look at 27. What is the largest perfect square that goes into 27? 9. So 3, I'm going to keep that 3 out there. 9 times 3. What's the square root of 9?
3.
So this square root of 9 is 3. That comes out. What's 3 times 3? 9. Square root 3. You multiply. Did you divide? Is that what you did? Yeah, no, you always multiply those outside numbers. So there's no do now other than what's up on the board. So you just get a piece of paper. Remember, they didn't have any paper. So, are you a visitor?
My child, yeah, she's a visitor.
So you're a visitor. What grade are you in?
9.
So you've done this.
I think we're on that. Oh wait, yeah.
You want to help me with this one? No? Oh, you're no fun. Okay. 5 square root 20, right? What is the perfect square that goes into 20 equally? 4. So I rewrite this as 5 square root 4 times 5. Which is the perfect square? The 4. The 4 comes out. What's the square root of 4? 2. You multiply those two outside numbers. So what's 5 times 2? 10 square root 5. Okay, so now I have 4 square root 48.
16.
And 16 goes into 48 how many times? 3 times. So 4 square root 16 times 3. And then this 16 comes out as 4. And 4 times 4 is 16 again, square root 3. Now, you always multiply. Don't make that mistake of adding or dividing. You multiply the two numbers, the one you pull out and the number in front. Okay, we got one more. Number 9 I just threw out there because I want you to realize that sometimes they can't be simplified, right? So number 8, 2 square root, what's the largest perfect square that goes into 75? 25 times 3. What's the square root of 25? 5. 5 times 2 is 10 square root 3. 9 square root 30 cannot be simplified because there is not a perfect square that divides evenly into 30. Right? Because it'd be 1 and 30, 2 and 15, 5 and 6, 3 and 10. No perfect squares that divide into 30. Peter, you're looking at it weirdly. Can I answer a question? Just digesting. Now, the reason why I had you do this is today we are going to be going over Pythagorean theorem and their applications and the converse of the Pythagorean theorem. Because I have a sprained ankle, who would like to pass these out? Oh, Ben's got you. No, you did not get the lowest.
How are you feeling today?
I got embarrassed, but the good thing no one was around because I was trying to load the copy machine with the paper that I had stashed away because we were out of paper, and I fell on my room. And I'm like, you didn't do bad. Let me find I'll tell you what the grade is. 83. That's a good grade. That's a B.
Okay, thank you.
Okay.
So do I need it?
No, because they're not in the grade book yet.
Okay, perfect.
Hi, what's your name? Okay, so today students will use Pythagorean theorem to find missing side lengths, including from real-world applications. Students will be able to apply the converse of the Pythagorean theorem and determine if a triangle is obtuse, acute, or right 80% of the time. So, it works. A and B are the two legs of the right triangle. This only works on right triangles, okay? Now, the legs are what makes the right angle. The corner. And they could flip, they can turn, they can, do things with it so it doesn't look nice and straight. But you have to be able to recognize A and B. Doesn't matter which one you call A, doesn't matter which one you call B. But what really matters is C. C is what we call the hypotenuse. Everybody say that. Hypotenuse. A hypotenuse is always across from the 90-degree angle, right? It's opposite the 90-degree angle, and it's the longest side. Longest side. Oh, this got cut off. Opposite the 90-degree angle. Did yours get cut off on your paper? Sorry. So put 90-degree angle, and it's always the longest side. Have I lost anybody yet? No? I don't like to lose anybody. Oh, here's it again. With everything written. I don't know why I had 2 pages of it written saying the same thing. Okay. So let's look at how it works. So, this would be A, this would be B, this would be C. Step 1 is you would go ahead and square each side. So 3 times 3 is 9. 4 times 4 is 16. And it equals C squared. What's 9 plus 16? And the square root of 25 is 5. This is called a Pythagorean triple because it comes out as a whole number. If you are taking SATs or ACTs anytime soon, you should memorize some of the most common Pythagorean theorem triples. The only reason I'm saying that is because I have a 9th grader in here. Memorize your Pythagorean triples. You will thank me when you take your SATs. I saw your eyes light up when I said that. So, but those Pythagorean triples, 3, 4, 5 are common, but they have a bunch of other ones like 5, 12, 13, 7, 24, 25. There's a few of Pythagorean theorem triples. Okay, now, these are not triples. We're going to round these to the nearest 10th. I'm going to do the first one with you, and then you are going to work at your tables and do the second 2. Normally, I walk around and check your work, right? I can't walk around and check your work because my foot is still swollen. So, just help each other out at your tables, okay? So when I look here is the 90 degree. Label your C first so you don't get that confused. So across from the 90 is always the C. The other 2 are A and B. Does not matter which one's A or which one's B. I always put the smaller side as A, but that's just me. A and B. Now the first step, I'm going to substitute into the formula. Remember, it's A squared plus B squared equals C squared. So I'm going to put 2 squared plus 5 squared equals C squared. What's 2 times 2? 4. What's 5 times 5? Equals C squared. I add 4 and 25 together, and I get 29 equals C squared. Now, don't forget the last step, because yesterday we learned about the triangle inequality theorem. There is no way that this side length can be 29. You have to take the square root of both sides so you get what C equals. So you take your handy-dandy calculator, and it's said to round to the nearest 10th, so I'm going to use the calculator for that. If it said exact answer, then I'd have to leave it in. I would have to simplify like I did in the do now. So I'm going to go clear. Second square root 29. What did you say? 5.38. What would I round that to? 5.4. Oh, yeah, I'm going to round that to 5.4. And if you've had Miss Connie, she'll mark you wrong if you don't put your units. So we're going to put inches. Right? Okay. So you all at your tables go ahead and try to do X, Z, and JL. While they're doing that, if anybody has not seen their test and want to see their test, you can. Okay, so if you did the two problems correctly, you should have got 14.3 inches, 21.4 yards. Correct?
Yes, ma'am.
We feeling good? Okay, now that's if you're looking for the hypotenuse. There are times when we are given the hypotenuse and we are looking for a leg. When we are looking for a leg, we end up having to subtract because we have them on opposite sides of the equal sign. Instead of adding the squares, we subtract the squares. So here, our right angle would have been right here, right? Because here's the corner. So this would be A, B, C. You would substitute 8 in. 8 squared plus B squared equals 10 squared. 64 plus B squared equals 100. I subtracted the squares, and then you take the square root, which is 6. Now, I am going to take a minute just because we have someone else in here, and it's a good idea for you guys to know this. That remember when I said 3, 4, 5 was a Pythagorean triple? Remember that I said that's all number? All the multiples are triples. So what happens when I take 3 times 2? What's 3 times 2?
6.
What's 4 times 2?
8.
What's 5 times 2? 6, 8, 10. Ah, isn't that interesting? So, yeah, if you would have noticed that, like on an SAT or ACT, you wouldn't have to do all this work. You go, oh, it's a triple because I'm so smart. And so that would be 6. Okay, right? Did you know that? Ah, you learned something. Okay. So go ahead, and now we're doing finding a missing leg, but now we're reducing the radical. We are not giving the answer as decimals, but only if possible, because it may be, and I forgot the parenthesis there. So we are going to be we're leaving it as exact, no decimals. Do you want me to do this one with you, or you want me to do this one? Okay, A squared plus B squared equals C squared. Across from the 90 is C. Doesn't matter what I call A and B as long as C is correctly marked. So I'll call this A, I'll call this B. So then I'm going to have 6 squared plus B squared is equal to 9 squared. I get 36 plus B squared equals 81. I have to subtract those two numbers instead of adding them. So subtract 36 from both sides. I'm going to pop down here. B squared is equal to what? 45. And now I need to find the square root. B equals the square root of 45. Well, what perfect square goes into 45? 9. So 9 times 5 is 9 is the largest perfect square. When I take the square root of it, you get 3 square root 5. So this answer here would be 3 square root 5. Okay? Go ahead and do the next two. Of 9, but it's actually based on the 3, 4, 5 triple. If you would have recognized it, you wouldn't have had to do any work. Because 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. This had to be 9. I didn't do any work, really. Well, you all are smart too. You just need to learn it. I make it look easy because I've been doing it for over 25 years. So you would hope that I know what I'm doing after 25 years of doing the same thing over and over again, right? Yes. Oh, you could have done it the same way as you did the others. I just mentioned that there are what's called Pythagorean theorem triples, which means that you always get whole numbers. 3, 4, 5, and all the multiples of 3, 4, 5 are triples. Just be careful that that 15 is the hypotenuse and that these are legs. Well, what I noticed is this was 15, this is 12, so I put 3, 4, 5. When I multiply all these by 3, I get a triple, 9, 12, 15. So I just put 9. So I didn't have to do all that work. You can, right? Did you all got 9 doing the long way, correct? But if you are taking standardized tests that are timed, it's nice to know those triples. Or just keep doing the Pythagorean theorem. Either way works. Okay, so summarize. When you're given the 2 legs of a triangle, the ones that make the corner, you add the squares, take the square root. If you are given a leg and a hypotenuse and you're looking for another leg, you square, but you end up subtracting instead of adding, and then taking the square root, right? That's just a summary of what we did. So here's it mixed. So we're missing either hypotenuse or we're missing a leg. Go ahead and do these, and then we will talk about word problems and the converse. Hopefully y'all had enough time. Is that what you got for your answers?
Yeah.
8.5, 13.9, 17.3, 14.9. Okay. Now,
Okay, never mind. I got it.
I still get, wait. Okay.
Or 10 Here is 10. Here is 10.
Okay, can I go on now? Can I move? Okay, so converse of the Pythagorean theorem. Contractors use this all the time. If you have a contractor and he's trying to put a window in, he will check the diagonal with a ruler to make sure that he inserted it at everything at a 90-degree angle, that the framing is at 90 degrees. He knows, because he does it for a living, and so he knows that that diagonal should be a certain length for it to make a right angle. And if it's not, then he needs to go back and readjust it, because you don't want to install the window and then have to uninstall it, right? They're going to pre-check it. They'll probably check it 2 or 3 times. Unlike the people who put up my boards incorrectly and they're mismatched, right? They will make sure that a window is put and installed correctly, right? Same way with people who do tiling or flooring. It amazes me when I walk around and look at these square floors, how many times there's gaps and things aren't lined up. Look at the ceiling up here. People who put these type of drop ceilings in, they lay groundwork going this way and this way. They lay lattices. They have to make sure they're always at a 90-degree angle so that these little square pieces will fit in there. So they're always checking to make sure that it's a right angle. And one of the easiest methods to check to see if it's a right angle is to measure the diagonal and use the converse of the Pythagorean theorem. So it is used in real life. Dun, dun, dun. Right? So, notice how I put the C's on the left, though. You are allowed to use this on your test, but when you do this, make sure you put the C squared on the left because you're comparing. So if C squared equals A squared plus B squared, we are in good shape. Everything's 90 degrees. It's a right triangle. If it's less than, then I have an acute triangle so that it's less than 90 degrees. And then if it's greater than, then I have an angle that's greater than 90 degrees. It's an obtuse triangle, right? Any questions on this so far?
No.
C would always be the largest side because you may, largest side, and then you would put the two smaller sides on this side, okay? Two smaller here. But this would be your largest. So let's try one of these. So I'm going to do this one, and then you're going to do the other ones, okay? So, which is the largest side? 30. So that's going to be my C squared, right? 30 squared, I do not know, so I put a circle here. I don't know why this confuses students. I don't know if it's equal yet. I don't know if it's greater than. I don't know if it's less than. I have to do the math. So I put a circle here as a placeholder for me to put equal, less than, or greater than, right? Okay, so then over here I'm going to put 14 squared plus 24 squared. So use your handy-dandy calculator. This would be, what, 900. I could do that one in my head. And this is, I'm just going to do it all at once. 14x squared plus 24x squared is, 772. So it would look like greater than, right?
Yeah.
And if I go back up to my chart, here's my chart. It would be an obtuse triangle. So this would be obtuse. Okay, you try to do number 2 and 3, please. Okay, so is this what you got? Obtuse, acute, and right?
Yes.
And who uses this?
Builders.
Builders use this all the time. A master builder will use it all for doors and windows. Make sure everything's nice and right. Yep. Or framers. Yeah, carpenters. Okay, so word problems. I always smile when I see this one because when I made this PowerPoint a long time ago, and Brooke was a former high school student of mine. Okay, Brooke is fishing from a small boat. Her fishing hook is 3 meters below her, and the fish is swimming at the same depth at the hook, 9 meters away. So how far down is the hook? No, this would be 3. This is 9. And then how far away is Brooke? So Brooke is sitting right here. Here I am. Here's Brooke. How far away is she from the fish? So that would be C, right? Because this would be A and B. So it'd be 3 squared plus 9 squared. And it says exact answer equals C squared. So 9 plus 81 is equal to C squared. 90 is equal to C squared, not decimal. Exact answer. So exact answer means that I look for the largest perfect square, which 90 would be 9, right? The square root of 9 is 3. So C is equal to 3 square root 10. And that's in meters. Can I go to the next one?
Yes.
Okay, the hard part on the SATs, ACTs, ASVAB, or if you're taking like a business, like a skills test or an entrance test to college, is they don't give you the picture. I was nice. I gave you a picture. But a lot of times they don't give you the picture. And you have to, and you don't know if it's going to be Pythagorean theorem or not. You have to read the problem, draw a picture, and then realize, oh, that's a right triangle and I'm missing a side length. So you can do the Pythagorean theorem. Does that make sense?
Yes.
So, Trent is decorating a ballroom ceiling with garland. Do you all know what garland is? Yeah, like Christmas tree. You wrap the garland around. It's fuzzy and colorful. Yeah, garland. The width of the rectangular ceiling is 16 meters, and the diagonal distance from one corner to the opposite corner is 20 meters. How much garland will Trent need for the length of the ceiling? So if I'm like this, it's saying that this is 20 because that's a diagonal, right? Length and width really doesn't matter which one you call length and width because I could turn a rectangle around and then like here's a rectangle, right? If I call this length and call this width, but then turn it, the sides don't change, but I may call this width, this length. It doesn't really matter as long as the outside one is a length and one is a width. So, I'm going to call this 16. Is that fair?
Yes.
And they want to know the length, like how much garland does it take for this length? So this would be like A, B, and C. So 16 squared plus B squared has to equal 20 squared. You would hope a ceiling has right angles, unless somebody did something wrong. So your handy dandy calculator, what is 16 squared? 256 plus b squared is equal to 400. I'm going to subtract 256, which, so b squared is equal to 144. When I take the square root of both sides, b is equal to 12 meters. I don't put those meters on. Okay? We good?
Yes.
Who here has bought a TV recently? Anybody here bought a TV recently? When you purchase a TV and they advertise it, do they give you two numbers or one number?
Two.
Do they give you two numbers?
1 in inches.
Yeah, they only give you one number.
What?
What in the world are they talking about when they only give you one number when they're talking about a television? It's the diagonal.
Oh, yes.
Oh, yeah, the length.
One.
It's the diagonal of the rectangle, right? That's what they're giving you. Why? Why do they only give you one number, and why do they use the diagonal?
Because any way you turn it, it's the same.
That correct? The diagonal would be the same either way. It's also the longest side. It's going to be the longest measure, right? So it feels like they're talking about a bigger number because it's going to be the longest number that you're going to get. So whenever they do that, they're actually doing the Pythagorean theorem and giving you the diagonal length. That's what they're giving you. Just food for thought. You learned something new. Okay, here's Miss Connie's class. This is physics. walks 2 kilometers south. So if Santos is here
The distance?
and walks 2 kilometers south, so south is this way, right? And then a certain amount of kilometers east, let's say north, south, this is west, this is east. So I'm going to go this way, but I don't know how long. This is question mark. And he ends up 5 kilometers from his starting position. So this is 5. What is that called? What are the two? Displacement and then what's the other one? What? Yeah, one is but anyway, this is the displacement. So this does come in handy for physics. So because I'm walking from south and then due east, this should make a right angle here. And so then you would just do the Pythagorean theorem. So it would be A, B, C. So you would have 2 squared plus B squared equals 5 squared. What's 2 times 2? 4 plus B squared equals 25. You subtract 4 from each side. B squared equals 21. Take the square root. So what's B equal to? What is it? 3 or 3.7?
4.6.
4.6. And that is what? Kilometers. So this would be 4.6 right here. That's it. I gave you some samples.